morning children. Today we are doing complex numbers exercise 2.3. In this we are checking associative law in addition as well as multiplication of complex numbers. Given Z1, Z2 and Z3, we want to show that Z1 plus Z2 plus Z3 equals Z1 plus Z2 plus Z3. So we'll find out LHS separately and then RHS separately. What is LHS? Z1 plus Z2. Z1 is 1 minus 3i and Z2 is minus 4i. By adding this, I get 1 minus 7i. So this is the answer for Z1 plus Z2. With this, add Z3. So Z1 plus Z2 plus Z3 equals. Z1 plus Z2 answer is 1 minus 7i and Z3 answer is 5. Total will be 6 minus 7i. So the LHS that I arrive at Z1 plus Z2 plus Z3 equals 6 minus 7i. We shall proceed to the RHS. RHS, first I shall find Z2 plus Z3, whatever comes in the bracket. So Z2 plus Z3 equals Z2 value minus 4i. Whenever real part is missing, you can put 0. Z3 is 5. By adding 5 minus 4i. So this is the answer for Z2 plus Z3. Now I want Z1 plus Z2 plus Z3. Z1 value is 1 minus 3i. Z2 plus Z3 is 5 minus 4i. Adding 6 minus 7i. So I get Z1 plus Z2 plus Z3 is equal to 6 minus 7i. So we are able to show LHS equal to RHS. Call this is 1 and this is 2. 1 comma 2 implies Z1 plus Z2 plus Z3 equals Z1 plus Z2 plus Z3, and this we say associative law is true for addition of complex numbers. Second subsection, Z1 1 minus 3i, Z2 minus 4i, Z3 5, and we need to show that the multiplication is associative. Z1 into Z2, that answer multiply with Z3. Z2 into Z3, then Z1 and that answer. Show both the sides are equal. So as before, let us proceed with LHS. In LHS, I want to start with a bracketed term. So that is Z1 into Z2. Z1 is 1 minus 3i and Z2 is minus 4i. Let us directly multiply 1 into minus 4i minus 4i. Minus into minus plus 3 4s are 12. I into I square. And I square value minus 1. Minus 1 into 12 minus 12 minus 4i. This answer I need to multiply with Z3. So Z1, Z2 into Z3. Z1, Z2 is minus 12 minus 4i into Z3 is 5. Just multiply 5 into minus 12 minus 16 minus 4i into 5 minus 20i. So this is LHS answer. Same way, we'll proceed on to the RHS. So for RHS, first find the bracket. Z2, Z3. Z2 is minus 4i, Z3 is 5. As I multiply, it's a simple multiplication, 5 into 4, 20. So my answer is minus 20i. And now I want to find out Z1 into Z2, Z3. This is equal to Z1 is 1 minus 3i. Z2, Z3 is minus 20i. As I multiply, 1 into minus 20i minus 20i, minus into minus plus, 3 into 20 60, I into I square. And we know I square is minus 1. Minus 1 into 16, minus 16, minus 20i. Just check both are equal. So call this as number 1 and call this as number 2. 1 comma 2 implies Z1 Z2 into Z3 equals Z1 into Z2 Z3. And that is the associative law shown in complex multiplication. Second question, first subsection. Again, 3 complex numbers are given and you want to show the distributive law. Z1 into Z2 plus Z3 equals Z1 into Z2 plus Z1 into Z3. So we'll start with the LHS. First, I want to find out the bracket. Z2 plus Z3. Z2 value minus 7i. Z3 value 5 plus 4i. Remember, I and I only I can add. Here, no real number means treat it as 0. 0 plus 5, 5. Minus 7i plus 4i is minus 3i. Now I want to find out Z1 into Z2 plus Z3. Z1 value 3. Z2 plus Z3 is 5 minus 3i. Just multiply 3 into 5 minus 3 into 3i. So this is LHS answered. To proceed with RHS, find out Z1 into Z2. Z1 is 3. Z2 is minus 7i. As I multiply, 3 into minus 7i minus 21i. Now I want to find out Z1, Z3. Z1 is 3. Z3 is 5 plus 4i. As I multiply, 3 5s are 15. 3 into 4i, 12i. And when I want to add Z1, Z2 plus Z1, Z3 equals to, here again no real number, treat it as 0. 15 plus 0, 15. 12i minus 21i minus 9i. Call this as number 2 and this as number 1. So this is Z1 into Z2 plus Z3 and this is Z1 Z2 plus Z1 Z3. 1 comma 2 implies Z1 into Z2 plus Z3 equals Z1 Z2 plus Z1 Z3, and that is the result to be shown. So we say multiplication is distributive over addition in complex numbers. Second subsection, we want to show Z1 plus Z2 into Z3 is Z1 Z3 plus Z2 Z3. Somewhat similar to the previous problem. First we'll find out the bracket. Z1 plus Z2. Z1 is 3 and Z2 is minus 7i. If I add both, it is 3 minus 7i. This answer I want to multiply with Z3. So Z1 plus Z2 into Z3 equal to, Z1 plus Z2 is 3 minus 7i into Z3 is 5 plus 4i. When both are complex numbers, with I, without I, let us remember this multiplication procedure, real and real. 3 5s are 15. Minus imaginary and imaginary. Already one minus, here one minus. So minus into minus plus. 7 into 4, 28. So when I do this arrow mark multiplication, I see only the numbers, not I. 3 5s are 15. Minus of minus is plus. 7 into 4 is 28. then plus I into the imaginary part. Real and imaginary, imaginary and real plus symbol. Real and imaginary, 3 4s are 12. Don't put 12I is already here. Then minus 7 into 5 minus 35. Simplifying this answer, it is 43 minus 23I. So this is LHS Z1 plus Z2 into Z3. Call this as number 1. Now I want to find out what is Z1 Z3 and Z2 Z3. So Z1 Z3. Z1 is 3, Z3 is 5 plus 4I. As I multiply, 15 plus 12I. Z2 Z3. Z2 is minus 7I and Z3 is 5 plus 4I. As I multiply, minus 7I into 5 minus 35I minus 7 4s are 28. I into I square. And we know I square is minus 1. Minus 1 into minus 28 is 28 minus 35I. Now I need to add these two. So Z1 Z3 plus Z2 Z3 equals 15 plus 12I, 28 minus 35I. We are adding. So my answer will be 15 plus 28 is 43 minus 35 plus 12 is 23I. Call this as number 2. So already we have shown 1 and now 2. So we say 1 comma 2 implies Z1 plus Z2 into Z3 equals Z1 Z3 plus Z2 Z3, and that is the result. Question number 3. We are given 3 complex numbers and we need to find the additive and multiplicative inverse of Z1, Z2 and Z3. Now what is the additive inverse? Z1 is 2 plus 5I means the additive inverse will be minus Z1. Remember, for plus 7, minus 7 is additive inverse. So, for plus Z1, additive inverse means minus Z1. And what do you mean by minus Z1? Just change the symbol for both. It will be minus 2 minus 5I. The next idea, I want the multiplicative inverse. What is the formula for multiplicative inverse? For plus 7, I say the multiplicative inverse is 1 by 7. Similarly, for Z1, the multiplicative inverse is 1 by Z1. It is nothing but 1 by 2 plus 5I. And let us remember, we do not allow complex in the denominator. So whenever complex number comes in the denominator, multiply and divide by the conjugate. So 2 plus 5I means I alone change the symbol. 2 minus 5I. And how do I multiply? The denominator, it is A plus IB, A minus IB. Remember, in the earlier classes we have learnt A plus IB into A minus IB is A square plus B square. A plus IB into A minus IB is A square plus B square. And the numerator is 2 minus 5I. Simplifying this answer, 5 square is 25 plus 4 is 29. So we get 29 out. So let me put it as 1 by 29 and I have 2 minus 5I. So this is the multiplicative inverse of Z1. We'll proceed with Z2. So Z2 is minus 3 minus 4I. The additive inverse will be minus Z2. That is, change the symbol for both 3 plus 4i. And the multiplicative inverse is 1 by Z2. So it is 1 by minus 3 minus 4i. Multiply by the conjugate, minus 3 plus 4i. In the numerator also minus 3 plus 4i. Minus 3 plus 4i by the denominator is square plus square, because it is of the format a plus ib into a minus ib. Square, 3 square is 9. Minus 3 square is also 9 only. 4 square is 16. So I can write 1 by 16 plus 9, 25 into minus 3 plus 4i. Now based on this, try for Z3 yourself. Thank you.